Now, today we will do a little bit of derivatives or differentiation. In particular, we will do only calculation about the derivatives or the differentiation. Of course, I will focus on IB program, but overall, this is the same for all the programs. So today, again, I will not go into the details of the geometric meaning of the derivative, how we can use advanced derivatives, like optimization or related rates, and there are many subtopics. But today we will focus entirely on the calculating derivatives or differentiating functions with the tools that we have in a basic level. In order to start, well, if you want to start with the how to calculate the derivatives, we always start with the power functions. Sorry, I have to fix this. Okay, so we always start the power functions. So let's go. Let's say that we have a power function, which means x to the power of n, for example, right? Let me zoom in and write it like this. Okay, let's say that we have x to the power of n. How do we find the derivative of x to the power n? Okay, derivative of a function is either written by this dash that you have here, or you can also write dy divided by dx, which means derivative of y with respect to x. Okay. Now, these two things is the same meaning. There's no difference. Sometimes they ask in IB inverts that to find the slope of the tangent line, differentiate the following function, find the derivative, etc. And those things maybe we will come in the next video when we will talk about geometric meaning of the derivatives. In any case, now how do you find the derivative of a power function? Well, it is equal to, we take the power, whatever it is, bring it to the front, and decrease the power by 1. So it would be n times x to the power of n minus 1. Very simple example for this would be following. Let's say that we have x to the power of 7. Derivative of this would be equal to 7 goes down, so 7 times x to the power of 7 minus 1, which is 6. Okay, that's quite easy. What if we have, let's say, 2 times x to the power of 5? Well, in this case, you need to recall what we have just seen, okay? So the rule about the power functions, so how to find the derivative of a power function, is related to the unknown itself. So if we have a coefficient, which means the constant in front of your unknown, this is your unknown, this is your coefficient, it doesn't say anything about the coefficient. So we don't have to think about it, right? So if we find the derivative of this, I just leave 2 as it is, because the rule doesn't tell me anything about it. So I have 2 times. Now I bring the 5 down because I need to derivate x to the power 5 and multiply it with x to the power of 5 minus 1, which is 4. And this would be equal to 2 times 5, which is 10, times x to the power of 4. And that's all. This works with any power or with any similar expression. All you have to do is take the power, bring it to the front of the unknown, and decrease the power by 1. The little trick that they usually do in IB is the following. They give you a power with the negative sign. Of course, the rule applies in the same way. So derivative of this would be minus 1 times x to the power of minus 1 minus 1, which is equal to minus x to the power of minus 2. Okay, now we still apply the same rule as we have here, although in IB, they prefer to ask you or to transform this expression into this form first and ask you to find the derivative afterwards. Okay, this is dash. This is not a 1. Okay, so but we know already that x to the power of minus 1 is actually equal to 1 over x. We know that x to the power of minus 1 is equal to 1 over x. Why? Because this negative sign in the power means you just need to invert your expression. X is usually written as alone, but it's also equal to x divided by 1, right? So if I find the derivative of x, okay, or let's say x to the power of minus 1, that means I need to invert my x divided by 1. So this would be, sorry, not the derivative, I'm mistaking it. So if I want to find the negative power of x, let's say, that means that I need to invert my x, okay? So this means x divided by 1 to the power of minus 1. And again, this negative sign means you just need to invert or replace numerator and the denominator between themselves. So this would be equal to 1 divided by x to the power of 1. Okay, so negative sign goes away and the value itself stays. Okay, so if it was, let's say, x to the power of minus 2, then this would be equal to 1 over x squared. The power itself stays, but the negative sign goes away. Now, in IB, as I said, they usually ask the negative sign, negative powers in terms of the fractions. So they write, for example, 1 over x. So in order to be able to use your rule, which is here, you need to realize that 1 over x is actually x to the power of minus 1. So you write x to the power of minus 1 dash. Now you can use the formula. Minus 1 goes down, then x to the power of minus 1 minus 1. And then this would be equal to, as we said above, minus x to the power of minus 2. This is the very common trick that they use in IB, but overall the rule doesn't change. You just have to take the power down and decrease the power by 1. Okay, now there are a few rules that we need to know while we are derivating functions or finding or differentiating functions, let's say, finding derivative of functions or differentiating functions. The first rule, there is no name for this, but if you want to find the derivative of two functions, okay, when while we are adding them, or let's say even subtracting, doesn't matter, okay, then derivative of this expression will be equal to f derivative plus or minus whatever sign they have between them, g derivative. This means that if I'm finding a derivative of a very long expression where I have pluses and minuses between other expressions inside this expression, then I can take the derivative of each individual expression and then add or subtract them later. So for example, we have x to the power 4 plus 3x to the power 7 minus 2x to the power of minus 1. Okay, now this is tricky. What will be derivative of this? Well, this will be derivative of x to the power 4 derivative plus, because we have plus between them, 3x to the power of 7 derivative minus, because we have minus now, right? Derivative of 2x to the power of minus 1, right? Now what happens? Derivative of x to the power 4 is 4 times x to the power 3, right? Power goes down and we decrease the power by 1. We have 4 times x to the power of 3. Then we have 3 times x to the power of 7. Again, we bring the power down. So 3 stays wherever it is. And we bring the 7 down. And then we multiply it with x to the power of 6. Okay. Then we have minus. Now here I'm going to use parentheses because I don't want to mess up with the negative values. I bring the minus 1 down. I multiply this with 2 because 2 was the coefficient. Okay, it doesn't matter which one I write first, it's just all the multiplication. So minus 1 goes down, and then I have x to the power of minus 1 is minus 2, right? Now, so this will be equal to 4x cubed. 3 times 7 is equal to 21, x to the power of 6. And then you have minus multiplied with minus, which will become plus. 1 times 2 is 2, and then you have x to the power of minus 2. So the thing here, the goal here is to show you that, in fact, when you find derivative of expressions between two functions, where you add them or subtract them, you can do this. You can find the derivative of each expression individually, and then add or subtract them based on whatever sign they have between them. Okay. Only thing to be careful here is expressions like this, because you have to be careful. You have a minus in front of them, or let's say plus, doesn't matter. But when you bring the power down after you find the derivative, that's what we did here, right? We have this expression, and the minus 1 went to the down in front of the x, or 2, doesn't matter. You have to be careful with the signs. You had minus already because of the subtraction, and now you have minus because of the power went down. So you have minus minus, which is plus. Okay. Now, this is the first rule that you need to know, but important 3 rules are product rule, quotient rule, and the chain rule in derivatives. So let's see how they work. Okay, product rule works in the following way. Maybe actually let's start with the few other basic derivatives. So we had x to the power n, which is your power function. Another common derivative, so the derivative of this would be equal to n times x to the power of n minus 1. Another common function that they use very often in IB is the sine x. It's a trigonometric function, and the derivative of this would be equal to cosine x. And the derivative of the cosine x would be equal to minus sine x. And one more, derivative of ln x, which is also, of course, a log at the base of e x, is equal to 1 divided by x. These four are the most common things that they ask you to calculate in derivative questions in IB. Of course, you have other derivatives as well, but I think these are the most common. And one more is that e to the power x derivative will be equal to itself, e to the power x. Okay, let me do like this. Yes. So these 5 derivatives or rules for these derivatives, actually derivatives, are the most common and the most used derivatives that they have in IB exams. So the first one is the power functions. We already dealt with it. Then we have a sine of x, derivative equals to cosine x. This is one single line. Same for the cosine x, but we have a minus sign in front of it. Just be careful here. And then one single line for ln x, which is equal to 1 over x after derivatives. And finally, derivative of e to the power x is equal to e to the power x, and which is itself, of course. Okay, these are the 5 basic derivatives that we really need in IB. Now we have 3 most important rules in calculation of the derivatives. So again, they are called product rule, quotient rule, and chain rule. Let's see what we have. So if we have a product of 2 functions, let's say f times g, and we want to find the derivative of this, okay? For example, f is x plus 1, and your g is x squared. Both of these functions are dependent on x, of course. Let's say that you multiply them. Okay, how do you find the derivative of this whole thing? Well, the rule says, product rule says, you have to find the derivative of the first one, multiply it with the original of the second one, okay, and then add to it original of the first one multiplied with the derivative of the second one. That's all the rule says. Let's apply this. Let's say that we have x plus 1 times x squared derivative. Okay, rule tells us we have to find the derivative of the first one. Okay, derivative of first one is the derivative of x plus 1, right? Let me actually write it down step by step. Rule says I have to find the derivative of this one first, okay, and then multiply it with the original of the second one, which is x squared, and then add original of the first one, which is x plus 1, and multiply this with the derivative of the second one. Okay, now how do I calculate this? Derivative, as we said previously, since we have a plus between x and 1, I'm going to find the derivative of x and 1 separately and then add them. Okay, derivative of x is equal to 1. How? X to the power of 1 is derivative is equal to 1 goes down, it will be 1 times x to the power of 1 minus 1, which is equal to 1 times x to the power of 0. But this is equal to 1, so this means 1 times 1 is 1. Perfect. What's the derivative of x? X1, or let's say any other constant actually? Well, it's actually equal to 0. But how do you find it? Why it's equal to 0? Because next to every single constant, you can always write x to the power of 0, right? Because if you want to apply the rule of the power functions, you need some unknown, right? You need to take the power of the unknown, bring it to the front, and decrease the power by 1. But right now we had only 1. 1 is not an unknown, it's just a constant. But next to it, we know for sure that there's x to the power of 0. Why do we know this, by the way? Because x to the power of 0 is equal to 1, and 1 times 1 is itself. So this thing, writing this here, x to the power of 0 next to the 1, doesn't change anything. What it changed, it just transforms 1 into different form, okay, with the same value, of course. It's still equal to 1, but it has a different form, right? Why we need a different form? Because we want to apply the rule of the derivative for the power functions. Now, derivative of this As I said, 1 stays as 1 because it's a coefficient. Power goes down, and then we decrease the power by 1. So this would be equal, whatever I have here or here doesn't matter. Since I have 0 in between them, it will be equal to 0 because I'm multiplying everything with 0. So every constant value has a derivative of 0 because in any case, they have a x to the power of 0 next to them as a product, and then you bring that 0 down, which means you're going to multiply 0 with everything else that you have. Okay, that's why it will be equal to 0, because 0 times anything is 0, which means at the end, a derivative of any constant will be equal to 0. Okay, now derivative of x plus 1 now becomes 1 plus 0. Derivative of x is 1, and derivative of 1 is 0. So I have 1 plus 0 times x squared. Okay, no problem with this. And then I have x plus 1 times derivative of x squared. What's the derivative of x squared? Well, I bring the power down, I decrease the power by 1, and it becomes 1, right? So it becomes 2x. Now I can simplify this even further. 1 plus 0 is 1. 1 times x squared is equal to x squared. No problem with this. X times 2x is equal to 2x squared. 1 times 2x is equal to 2x. So your result is you have x squared here and 2x squared here, which means you have total of 3x squares and plus 2x. This will be your derivative of this function here. Okay. This was the first rule, product rule. Now let's see how it works with the quotient rule. Why I'm moving fast here? Because the quotient rule will be more or less the same idea. So we will have another example. Quotient rule tells if you have two functions and you divide them, then the derivative of them will be equal to derivative of the first one times the original of the denominator minus original of the numerator times derivative of the denominator divided by square of your denominator. Let's try with x plus 1 and x squared, right? Let's say that we have x plus 1 divided by x squared. What's the derivative of this? Well, formula tells us I have to find the derivative of the x plus 1 first, multiply it with the original of my denominator, which is x squared, sure, minus original of my numerator, which is x plus 1, multiplied with the derivative of the denominator, which is x squared dash, right? Divided by square of my denominator. My denominator is x squared, and I have to take another square. Let's calculate. We said that the x plus 1 derivative is equal to 1. 1 times x squared. X squared is just x squared. Minus x plus 1 times derivative of x squared. We already found it. It's equal to 2x. And of course, in the denominator, I have x squared squared, which means x to the power of 4. Okay. Now, again, I have x squared from here. If I multiply x with 2x, I will have 2x squared. If I multiply 1 with 2x, I will have 2x. Why I have minus and minus here? Because I have a minus here, which affects everything that is multiplied here, right? Now, because there's a plus here, and minus times plus will be minus. This is divided by x to the power 4. Let's simplify it even further. X squared minus 2x squared is minus x squared. And then you have minus 2x, which is no problem. I can write it like this, divided by x to the power of 4. And at this point, you can simplify it actually a little bit more, because you have a product x here as a factor and the x here. So you can write your numerator in the following form. You can write this thing, this numerator is equal to x times minus x plus, of course minus, not plus, minus 2. Why? Because now x times minus x is equal to minus x squared. X times minus 2 is equal to minus 2x. So I can write this down. Divided by x to the power 4. Now, one of the x's will cancel out. X will go away from here, and this 4 will go ahead. You will have 3, because one of the x's will cancel out. Then the final result will be equal to minus x minus 2 divided by x to the power of 3. Okay. And that's all. And that's all the result for this example. One more thing about these expressions, that has nothing to do with derivatives. When you have such an expression, they might try to, or might ask you write it in a different form, or might give you in a different form. This minus you can write as the following way. So you can write minus x plus 2 divided by x cubed. This is also possible. So because minus times x is minus x, minus times 2 is minus 2. And then this would be equal to minus x plus 2 divided by x cubed. Okay. So if you have minus in front of your whole fraction, okay, then that minus affects your whole fraction, either numerator or denominator, because you need to affect one of them, but it's the same thing. So basically you can convert them to here and then from here to here. This has nothing to do with the derivatives, of course. This is just a simplification or transformation of an expression to another form, let's say. Okay, all good. Now we will check one final rule, which is called chain rule. Okay, chain rule is for the functions where you have a function inside a function. Let's say that you have f of g of x. Okay. Example for this could be sine of 3x. Okay, and I have to find derivative of this. Okay, I will write down the formula first, and then I will calculate here. Why this is sine 3x example of what I have written above? Because 3 in itself, 3x in itself is a function. I'm taking an unknown, which is x. I'm multiplying by 3. This is a function. So this is my function. But sine is another function, sine of x, right? Sine of something. So I have a function inside the function. I have 3x as a function inside the sine function. So I have a function inside a function. Now, what will be the derivative of this? Well, the rule says the following. It says that if you want to find a derivative of such expressions, you have to find the derivative of outside, which means you have to find f dash of g of x and multiply it with the derivative of inside, which is gx, right? Which is g dash x, since we are talking about derivatives. Now, what does it mean? It means the following. Let's say that we have this example, sine of 3x. Now, rule says it's better, in my opinion, to repeat this and understand it verbally, and then understand it with notation, because it makes more sense verbally, in my opinion. Also, in notation, it makes sense. Of course, it's mathematics, but you need to get used to it and then understand it, etc. But verbally, it will make you more close to the rule. Okay, so we have to find the derivative of outside first. Outside means outside function, which is sine function. Okay, what was the derivative of sine x? It was equal to cosine x, right? Now, I am going to change sine to cosine. Perfect. Now, instead of x, I have 3x. So I write 3x. Okay. Instead of x, I have 3x. So I have cosine of 3x. I found the derivative of outside. Perfect. I treat whatever I have inside sine as a single thing. Okay. Now I have to multiply this with the derivative of inside, which is 3x. And derivative of 3x is just 3. So your result is 3 times cosine of 3x. Of course, let's put it like this so that we don't confuse ourselves. 3x is inside cosine, and this 3 here is a coefficient. Okay, so you have 3 times cosine of 3x. Let's do one more example. Let's do maybe something a little bit easier. So let's say that we have this would be interesting. Let's use green. I can do this. Yes, let's do following. Let's say that we have 3x to the power of 4 plus 7 to the power of 2. And I want to find derivative of this. Now, how do we understand that we need to use chain rule here? Well, because this power here already defines a function for you. But let's go step by step, actually. You have an x here. You take the power of it, you have a function, right? You have a power function. So you already have a power function and actually a linear function here because you have a plus 7, etc. That's all good. But then because of this power, you have another function here. You are taking the power of something. So this is another function. So you have a function inside a function. So what we're going to do is the following. We are going to find the derivative of outside, which is our power function. So which means I'm going to take the power, bring it to the front, and decrease it by 1. So it will be 2 times 3x to the power of 4 plus 7, right? To the power of 1, because 2 minus 1 is 1, but I don't have to write power 1, it's just itself, that's all. But I have to multiply this now with the derivative of inside, which is 3x to the power 4 plus 7 derivative, of course. Once I found this derivative, I will be done. So let's do it. This is equal to, again, 3 times x to the power 4 plus 7. Nothing changes from the initial part. This 2 times these things. And now, what's the derivative of 3x to the power 4? Well, 4 comes down. We have 3 times 4, which is 12, right? Then x to the power of 4 minus 1, which is 3. And derivative of a constant, 7 is a constant, it's just a number, is 0. So I don't have to even write it. I will just do this, because anything plus 0 is just itself. So I'm just going to write it like this. And that would be all. After this point on, you can simplify it and write a single form. You can open these brackets and you can write it as a single expression. It's possible. But the point is that now at this point, you already applied your chain rule and you are done with derivative. From this point on, again, it's just a simplification, opening brackets, and etc. At this point, you already got all the points that you need from the derivative, especially from the chain rule. Okay? After this, again, it's all about the simplification, opening the brackets, multiplying the coefficients, and etc. Now, let's just quickly summarize what we have done and then wrap up the video. So what we had, we first talked about the power functions. How did we find the power function? And after that, we talked about other similar basic functions that we need to know the derivative of in IB. The first one is, again, power function. Second one, this is the first one. The second one is the sine. Third one is the cosine. Fourth one is your ln x. And the fifth one is your e to the power x. These are the most basic functions that you need to know the derivatives of for IB, also for other international programs, I would assume. After that, we talked about adding and subtracting functions. We said that there's no name for this, but whenever you are adding or subtracting two functions and finding derivative of the sum or the difference, then you can find the derivative of each individual expression and then add or subtract them later, as we have here as a rule. Okay, this was an example. We have plus and minuses between these terms. So, and we want to find the derivative of the total thing, which means we are going to find the derivative of each individual thing here, here, and here, and then add or subtract them based on the signs that they have between them. Okay. Finally, after all of this, we talked about three important rules. The first one was about the power product rule, which was here, when we multiply two functions and find the derivative of this. The second one was about the quotient rule, which was here. It was about dividing two functions and finding the derivative of this. And finally, we talked about chain rule, which is about a function inside a function, and then we take the derivative of this. So product rule, quotient rule, and the chain rule are the most important three rules that you need to know while calculating the derivatives and or differentiating a function in IB or also in similar international programs. Another important thing is to know that when you add or subtract two functions and then take the derivative, you just have to do it separately for each term and then add or subtract them. That's another important thing. And finally, important thing, as again I said, is to know the basic important functions, fundamental functions that you should know the derivative of. So it is power function, which means x to the power of n, sine, cosine, ln x, and e to the power x. There should be probably a little bit more of these derivatives, but these are the ones that I can come up with right now. I think in your booklet you also have tangent of x derivative, but you can find it by using the quotient rule. Let's actually do it. I mean, let's. I think in your booklet you have it, but let's just have a look at it, just as a final thing, as an example for the quotient rule. So tangent x derivative. How do we know this? Well, how do we know the formula? Let's say you don't remember. Maybe you don't have booklet. You lost your booklet. Let's say. I don't know. I don't know if it's in booklet. I think it should be. Anyways, well, tangent x, we know that is equal to sine x divided by cosine x. Right? So finding the derivative of tangent means finding the derivative of this. That's good. Now I can use my quotient rule because I have a function divided by another function. What does my quotient rule say? It says I have to find my derivative of the first one, sine x derivative, multiplied with the denominator, cosine x, then subtract from it the original of the numerator multiplied with the derivative of the denominator, divided by cosine square x or cosine x squared. So what's the sine x derivative? As we said, it was cosine x, right? Now we have another cosine x here, so we multiply cosine x with cosine x. You have minus sine x, nothing we have to do with it. What's the derivative of cosine x? Well, derivative of cosine x is equal to minus sine x, right? Perfect. Then it is all divided by cosine square x. What do we have here? We have cosine square x minus times minus is plus because there is a multiplication between them. So plus sine times sine will be sine square x divided by cosine square x. So cosine square x plus sine square x, there is a rule that says that it is equal to 1, right? And the denominator, we don't have anything to do with. And that's your derivative for tangent. This is also known, if I'm not mistaken, as secant of x. I am not so sure. I always confuse them. Either secant or cosecant. I always confuse which one is which. But anyways, that's how you can actually get rid of the problem of memorizing a formula. Okay, because you can, if you don't know how to find the derivative of this, you just convert it to something that you can find the derivative of. You know that tangent is equal to sine divided by cos, right? If you don't know how to find the derivative of tangent, well, find the derivative of the sine divided by cos, because that you know how to do it, because now you know the quotient rule. And yeah, again, I'm not sure if it's secant or cosecant, always confuse it. Anyways, but yeah, you can check it out. I think at this point I will finish the lesson or video for today, and in my next video I think we will talk about geometric meaning of derivative, how to find maximum or minimum values, and how to find where the function changes its shape, and etc. So we will talk a little bit about geometric side of the derivative. For now, that's all. And thank you very much for listening. And don't forget to subscribe and like. And yeah.